Hey guys, it's Cugsley, and welcome back to another video. So I'm making this because I've been obsessing over the input system for a little while, even after I made my last kind of video on it, showing that I've since optimized it further. And I have reached, I'm pretty sure, as optimized as I can get this system where it matters. So let me just break this down here for you. This microchip right here, completely isolated, right? Nothing going in or out of it. I have managed to get this down from the original 11% when I had first created it, all the way down, let's isolate this, to 5%. It's like 4.9, I believe. Yep, 4.9 on wires and animations, and then 4.22 on things. So, the entire system, including the execution, right, which would be in here, of the actual like input customization, as well as the menu system for allowing the user to actually assign their inputs, all takes up a collective total of only 5%. So not bad. Some of the optimizations that I managed to do, I'm going to skim through it, just kind of show off what changed, is this. Actually, let me go into the older version so I can kind of show where it changed. So the older version of the system, which I last showed you guys, had this look to it, where when going in here, you would see that again you had your combination of both the user's input as well as what value the function is currently looking for. And then what I do is I look for common numbers that are associated with the addition of those two inputs. And some numbers are logically set to activate the function, others are set to not activate the function. For example, because your input values range from, fuck, see, these are back at 2 again. This is supposed to be 1 here. This is an old version. 1 and 3, right? You have this kind of setup here. What it ends up looking like, let's just put this up to 8. Or, no, sorry, up to 4? And then combined total of 8. Okay, yeah. So what the system ends up looking like in terms of like a I guess a value matrix is this, right? I'll just kind of get it done quickly for you. 0 means that both input and what it's looking for, so input and function call, right, are 0. Nothing's happening. So don't activate. 1 would mean that you're either inputting a value of 1 or the function is looking for a value of 1, but one or the other isn't on. So it's 0, which means that a value of 1 is like don't execute, don't do anything, right? Then a value of 2 means that 1 and 1 are on, which means a function call is at 1, inputs at 1 for a total value of 2, and hey, execute that. Now, going down the list, you end up with this situation here where there are a few numbers that you want to look for. Specifically, 2, 5, 6, 7, and 8. These are the values that the computer needs to look for to say, hey, if the addition of any of these numbers here, when decoded, equals a singular digit with any of these values, execute the function. The original system had it like this, where I combined all the values into a singular system here and looked to see, hey, are any of these larger than, again, old system, are any of these larger than or equal to 5? If so, activate the function. But I had an issue. The issue was, what do you do about looking for the value 2? Because if you notice, there are, 2 values in between here that you don't want to include. So I can't say if this is greater than or equal to 2, execute, because then if a 3 or a 4 are returned, which are both invalid, then it'll execute the function during invalid calls, which is not good. You don't want to do that, right? You want to only execute the function if these values in particular are present. So while this works for 5 and up, how do you get 2? Well, the original solution was to individually round each digit as it's decoded and then check to see if it's equal to, again, 4 is the old version, 2, right? And so if it equals 2, then we're good. However, as I'm sure you're noticing here, there's a lot of wires going out of this. There's these items here, there's these wires right here, and then there's this right here. I mean, there's a lot of stuff going on. How did I manage to fix this? Well, first, there were some unique issues that I came across that I couldn't quite do. And let me go into the newest version so I can show you some of those issues while also showing you what I did to fix them. So here, it's in this system here. I recently reorganized everything. So this is the new system. Way nicer, right? So one idea I had, which I managed to figure it out, but before I got to that point, was this. What if I combined all of the decoded digits back into a singular wire, which essentially creates an array, or like a list of numbers. So for example, all these numbers go in here, like if I were to add in a value slider, and let's set this up to a maximum value of this. Plug that in, and then, hey, look at that, right? So when I go in here, you see that it has a set value. And of course, they're rounding because, not rounding, but like there's decimal places because of the way the decoder works is it turns them into decimals. So what if I combine them into an array by putting them through a combiner? Because you can then split that back up, which means that it's able to save all the individual values. I found out that you can run an array through like a data modifier and maintain all of the values in that array and keep them individually, right? So this doesn't work for like comparison tools. Like if I were to say, hey, does anything here equal the number 2? It freaks the fuck out. Because it's like, oh yeah, something does equal 5 in here. No. I could say, does this equal 99? And it's still going to submit a value of 1. I could say, do any of these values equal 0? It still submits a value of 1. It still outputs, right? I literally can't control that. So using a comparison tool doesn't work, which means, hey, put this into array and then just say, hey, does anything here equal 2? Or is it greater than or equal to 5? If so, awesome. That doesn't work. Because again, it submits a true statement, or like a, hey, it outputs no matter what the input or output you're looking for is. So this is bad. This doesn't work. So fuck, what do we do? Well, I had an idea. Modifiers work. And another interesting thing is that if you get an array and you modify it or do whatever you want with it, and then you convert it into a singular value, right, by putting it through, say, a value slider, something interesting happens. What's interesting is it takes the highest value in the array and it runs with that one. That's a useful bit of information. So we have 2 things that we know. Well, 3 things. We know that we can create arrays. We know that we can individually, work with array systems. And we can say, hey, like for example, let's say that this is 6 and this is 7. There you go. That's. Are you rounding again? Oh shit! I forgot that the maximum is set to this here. Let me show you an example of what I mean. Oh fuck. There we go. So let me show you what I mean by like data can be processed. Put that at 6. Put these 2 at 5. There we go. Right? So we know that we can create arrays. We know that we can run an array through a like data modifier, right? And maintain like the integrity of the array, right? So it's still a combined wire. And we know that when we simplify an array into a singular value, right, it takes the highest value in the array and it runs with that. So how do we then search for numbers equal to or higher than 5 as well as 2, right? Well, there's no way to single out 2 from this array, at least supposedly. Because yes, we can look for numbers greater than or equal to 5. What we do is we simply do this, run this through, and it takes the highest number. Ta-da! Look at that, it works. How do we find 2? Well, with this here, there's not enough information. There's one more clue that we need. And I was playing around with a calculator when I found out something very interesting. So remember how I said that you can run an array through a data modifier and it maintains the integrity of the array? Well, the data modifiers that you can run it through include geometric ones, or trigonomic, I guess. trigonometric, trigonometric, huh? You can put it through trigonometry, including a sine function. This is extremely important because as it happens, if you create an array, if you round it out to whole numbers, right, and get rid of decimal places, and then you run it through a sine function, right, then what that does is that runs the entire array bit by bit through a sine function. And then if you pull it back out again, you now have this list right here of stuff. What this shows is every single number in our array rounded and then run through sine. And it just so happens that when you run a number through a sine function, 2 ends up being the highest number that results from like sine 1 through 7, right? The only one that's higher than sine 2 is sine 8. But if an 8 is generated, we already know that's good to go. So that leads to an interesting solution. What we can do is we can create an array, we can round it, we can route one output to just kind of a simple value slider here, look for the highest number. If it's greater than 5 or equal to 5, splendid. For the rest, though, run it through a sine function, then take the highest number, because the highest number is sine 2, which is 0.909, or 0.91 is what the calculator looks for. And then run that through a calculator. And what we just did is we just made it so that way 2 is technically the highest number in the array, and therefore it carries through to the value slider and is able to go through. So we were able to turn a system that checks for every single digit's value into a system that's able to find the highest number, which just so happens to be converted to 2. So you're able to save gameplay space by doing that. And what you end up seeing is this system when fully created. So voila, that was one of the main ways that I optimized the system. Some other stuff that I did to fix up was mainly with my menu logic, where, like, for example, I had a like calculator, a controller sensor in here that assigned values to the menus version of the variables, where now I just share this across both. And so then, I got rid of redundancies there. I worked with basically just trying to get rid of as much as I can in terms of processing. Like, I simplified this down to where it still works. Let's see here. This actually hasn't changed at all. This is still the exact same. So is this. So, I mean, not much changed aside from that main bit there, but this saved quite a bit. Everything else was mainly just getting rid of redundancies, trying to simplify my code wherever possible. But this right here saved an absurd amount of space, because a thorn in my side for a while, a really annoying gripe that I had with my system that I knew I could optimize, I just didn't know how yet, was how to simplify my, I guess, like comparison tool to where I don't have to have all of this, because this isn't good. I mean, having to check for every single digit's value individually with no other way to see if just anything equals to is inefficient and it's bad. So the fact that I was able to optimize that saved me a considerably larger amount of space than I actually expected. And as a result, if I were to go in here, pull out this microchip, and now check our system, this is 7% gameplay, 6.21 and 5.13. Just remember 6.21 since that's the biggest. And by getting everything fixed up and optimized, as well as, optimizing the menu and clearing some other stuff out, I got it down to 4.90, which means I've created a system that can do the following. Let me just put this back into a working player. You can go into it in scene without having to go to a main pause menu. You can assign values to all of your functions. You can assign the same button to several functions. You can reset. You can set to default. You can delete individual like assignments per function. You can also set multiple values or like multiple buttons to the same function. The actual display doesn't work because, again, I am not going to put that much gameplay effort into a like system that shows all the buttons that you assign to it, because that would be a lot of stuff to calculate. So it's a little bit of the UI side is lacking, but I'm not so worried about it. But like now every button that I press is the jump button, right? So you can assign multiple buttons to the same function. You can assign multiple functions to the same button. You can default and set your controls however you want. It is fully customizable and functioning. And so I managed to get all that done in under 5% gameplay. To give you an idea, the only system on Dreams that I was able to find that actually does lower than mine is a input remapper that remaps button to button as opposed to button to function. So the difference in that basically just means that whereas this system has a set list of functions that you're able to assign controls to, the other system on Dreams is a system that doesn't have any functions built in or kind of figured out with. It's just saying, hey, when you press this button, what do you want Dreams to think that you pressed? So it does a singular reassignment per button, like that you have, which is good, but it's a little more restrictive than this one is, just because you can't assign multiple values to the same button. Since again, you're not working with functions, you're working with individual values and buttons. You're essentially just remapping your controller. Whereas this one, you're doing a little like remapping plus a few other things. So this is the full working computer, all self-contained inside this microchip with no other wires going out, and 4.9% gameplay. Thank you for watching. I don't believe I'll have any other videos coming out with how I've optimized this, and I'm sorry that this video was a little longer than perhaps I anticipated it to be, but it was just really fun explaining how I kind of figured this out here. Just what my luck that Sign 2 happens to fucking work perfectly for me in this situation. Every other number plugged into Sign is either lower or a negative number. So, I mean, literally just chef's kiss. Pure luck that it worked out. Well, thank you for watching. I hope you guys have a wonderful night. And yeah, if you want to see how I make the system like as it is now, I can make a longer video where I show exactly how it works down to the nuts and bolts, wire per wire. But that's a time that's a time investment. So for you guys and for me. So if you want to see something like that, just let me know and I'll do it. But if not, then thank you for enjoying this. All right, you guys have a wonderful day, and thank you for watching. 5 fucking %. Hell yeah.